On November 19th, NASA announced its latest discovery. Object 3. Atlas may be one of the factors behind the current phase of intense solar activity. 3 Atlas quietly passes through the solar system while our star repeatedly produces X-ray outbursts, X-class flares, powerful coronal mass ejections, and falls into rare planetary geometric configurations. Telescopes are forced to use long exposures, stacking series of frames to pull the coma, faint tail, and thin jets of Atlas out of background noise. NASA has begun directly calling Atlas a comet, while the observing community remains cautious due to its unusual interstellar origin. At the same time, solar storms distort the radiation belts around Earth, and a quiet earthquake swarm appears off the coast of Japan. All of this seems to merge into one energy rhythm through which Atlas drifts, instead of being perceived only as a threat. 3 Atlas is like a gentle reminder that the universe still holds countless mysteries yet to be solved. And tonight, Earth still has the right to set all hypotheses aside for a while and peacefully sink into sleep. Before everything is revealed, let us slowly follow this path and ask ourselves, isn't 3 Atlas indirectly contributing to Earth's changes to such a degree that it forces sending an urgent message to all humankind? Outside your window, the night seems quiet, but nothing in the sky is truly resting. Far above the calm room, planets glide along their invisible paths, and 3 Atlas hovers between them. The solar system rotates like huge, slow clockwork. Each world keeps time using gravity, not ticking metal. Within this clockwork mechanism, Atlas becomes the unexpected hand that appears from outside the dial, moving to a rhythm not designed by local laws. Earth gently spins beneath your body, carrying you eastward into darkness, while Atlas drifts through the sun's faint outer wind. Cities dim their lights, but Atlas never sees night, only the constant grayness of interplanetary space. Mercury, Venus, Earth, and Mars orbit in a thin plane around the sun, while Atlas crosses this plane on a steep foreign trajectory. Known comets loop and return, but Atlas falls through the system only once, as if passing through a room it never planned to visit. Long before astronomers gave Atlas its name, the object had already wandered for millions or billions of years between distant stars. Now Atlas has become part of our sky for a brief moment, a guest quietly threading through the geometry of the inner planets. The sun's light envelops Atlas, lifting dust from the surface and drawing a faint veil behind this small, cold body. From Earth, this veil is barely visible. However, Atlas continues its patient motion, whether anyone is watching or not. Somewhere above the horizon, telescopes track Atlas as a tiny moving point, almost indistinguishable from background stars. For this point, our entire solar system is just another bright island on a much longer journey that Atlas hasn't finished. You lie motionless while Atlas moves endlessly. Your breathing rises and falls more slowly than orbits, but with the same quiet regularity. In this moment, your heartbeat, Earth's rotation, and Atlas's long path are all parts of one unfolding pattern. As you sink deeper into the calm of night, Atlas's story will follow the sun's wind a little closer. From the sun's surface, a bright disturbance swells and breaks free, like a thick wave of light beginning to rise. This wave is a coronal mass ejection, a cloud of charged particles and tangled magnetic field pushing into space. And Atlas is somewhere ahead, on its path. Behind your eyelids, the night is dark, but in the inner solar system, the coronal mass ejection expands like a slow, luminous tide. The sun exhales, and the plasma front begins racing outward at speeds of hundreds of kilometers per second toward the region where 3 Atlas is drifting. On quiet screens in distant control rooms, models turn this invisible wave into colored shells expanding from the sun. In these simulations, one of the shells passes directly through the line of Atlas's orbit, as if the wave drew a soft target around 3 Atlas. The numbers behind these pictures are simple at first glance. They take the speed of the coronal mass ejection, the sun's position, Atlas's known trajectory, and estimate a day almost like a scheduled meeting between the storm front and 3 Atlas. Every modeler knows the limits of these forecasts, and Atlas's story respects this uncertainty. Magnetic fields bend, solar wind density shifts, and the real wave may arrive earlier, later, or slightly miss the target from what the diagram shows around 3 Atlas. Nevertheless, the geometry is suggestive. The same active region that threw powerful flares toward Earth now appears to be sending one wide exhale into the flank of space where Atlas recently passed perihelion. In your imagination, the coronal mass ejection can be presented not as a threat, but as a moving, shining curtain spreading through darkness. Behind this curtain, 3 Atlas hangs like a grain of sand inside a huge, faint lantern, waiting to feel the change in the surrounding field. When the front approaches, the solar wind around Atlas may compress, the magnetic environment may rearrange, and 3 Atlas's coma may flutter or stretch. Nothing in this meeting is guaranteed, but the possibility turns Atlas's journey into a quiet experiment carved into the plasma around the sun. You sink deeper into the mattress while the wave continues moving far beyond your atmosphere and weather. Somewhere ahead of this moving shell, 3 Atlas continues its slow fall through the system, carrying its ancient silence toward what the sun's breath is about to write across its halo. The recent solar eruption spilled sideways from the sun, away from the direct line to Earth, but still within reach of Atlas. While terrestrial space weather forecasters relax slightly, 3 Atlas continues drifting through a region where the solar wind has grown restless. Before perihelion, 3 Atlas looked almost star-like, a condensed point with only the faintest hint of surrounding haze. Now the passage around the sun has changed Atlas, and observers describe a broad, diffuse coma swelling around the interstellar guest. Light from the sun scatters through dust and gas released from Atlas, stretching a soft, pale envelope outward in all directions. Behind this envelope, 3 Atlas carries a growing tail, a narrow river of material trailing downstream along the solar wind. Closer inspection of long, carefully stacked images reveals thin jets spraying from near the hidden nucleus of 3 Atlas. Each jet traces a line where sunlight, trapped gases, and complex surface layers on Atlas meet and return material back to space. A few weeks ago, many telescopes struggled to show any clear structure, and 3 Atlas hid inside background noise and atmosphere. Now the same systems using the same methods register a guest that appears undeniably active, where Atlas carves visible shapes in darkness. For comet scientists, this behavior feels familiar. However, 3 Atlas's interstellar origin gives each plume and each curve extra weight. Each new exposure suggests that Atlas is not a cold relic, but a responsive body still reacting to heat, gravity, and magnetic changes. As Earth moves onward in its orbit, the viewing angle shifts, and 3 Atlas slides into more favorable geometry for observation. From this new vantage point, Atlas's coma spreads sideways across the sky, allowing tails and jets to stand out more clearly. Somewhere between data and intuition, observers begin speaking of an awakening, as though 3 Atlas took a long, slow breath. This sense of awakening gives Atlas a quiet presence in the story, a character now ready to meet the approaching solar disturbance. You sink deeper into stillness, while 3 Atlas continues brightening each new night, placing Atlas further along its luminous arc. From here, Atlas's path leads to questions about plasma, magnetic fields, and how a solar storm can touch a guest from another star. Far from Earth, a simple question hangs over 3 Atlas's path. What happens when a strong coronal mass ejection sweeps across a small body like Atlas, wrapped in a thin cloud of plasma and dust? Even now, no one knows the true size of the solid core hidden inside 3 Atlas's glow. Early estimates suggested a nucleus just a few kilometers wide, but other readings hint that Atlas might be tens of kilometers across, heavy enough to hold a more complex history. Around this unseen core, sunlight warms buried ice and releases vapor, and escaping gas drags dust into space. On long exposures, 3 Atlas appears as a bright center with a wide coma, while a tail is pulled in the direction opposite the sun, showing how the solar wind is already shaping Atlas. Past missions to other comets, such as the Rosetta spacecraft, have watched what happens when a strong coronal mass ejection rushes through this delicate environment. In those cases, the magnetic field wrapped around the comet flipped, plasma around the nucleus reorganized, and the tail broke away in a clean, sudden disconnection before slowly rebuilding, as though the comet had exhaled and shed an old scarf of charged dust. Now the same possibility hangs over 3 Atlas. If a dense, fast-moving wave from the sun reaches Atlas's region, the magnetic sheath around 3 Atlas may be squeezed and twisted. Field lines could snap and reconnect, and Atlas's tail could thin, kink, or even separate entirely before a new tail begins to grow. For those watching the sky, This is not a disaster, but a rare experiment written in natural forces. 3 Atlas becomes a small laboratory, moving through the storm, silently testing how interstellar ice and rock behave inside a changing solar wind. As you drift towards sleep, the image remains simple and calm. Somewhere in darkness, Atlas travels onward, and the sun's breath approaches, ready to trace a bright temporary scar across 3 Atlas's halo before both return to quiet space. Around the world, small observatories and backyard telescopes turn quietly through the night. Each one waits for the faint light of 3 Atlas. Above mountain ridges and city rooms, domes open, mirrors cool in darkness, while Atlas slowly climbs higher in the sky. Night by night, the geometry between Earth, the Sun, and 3 Atlas changes. As Earth moves along its orbit and Atlas glides farther from perihelion, the line of sight tilts, giving observers a more sideways view of the halo surrounding Atlas. Earlier in the apparition, when 3 Atlas was closer to the Sun from our perspective, Atlas's tail stretched almost directly away behind the nucleus. From Earth, this meant Atlas's tail pointed mostly along our line of sight, hiding its true length and shape inside the coma's glare. Now the scene is different, and the slow shift favors those patient with Atlas. As the angle grows more oblique, 3 Atlas's tail begins sliding away from the coma's center across the sky, separating just enough for careful eyes to follow its curve. On computer monitors and control rooms, tracking software shows a tiny crosshair sliding over star fields as the telescope follows Atlas. Each exposure is a short whisper of photons that left 3 Atlas many minutes ago, carrying information about dust, gas, and solar wind wrapped around Atlas. Observers know that 3 Atlas is still faint and the sky must cooperate. Thin clouds, bright moon, or city lights can swallow the delicate haze around Atlas before it ever reaches the mirror. Those who travel to darker places do so for Atlas, standing under cold air and quiet horizons to capture more of the subtle light. In those places, 3 Atlas's glow can spread a little wider on the detector, hinting at the coma and tail still forming their full shape. From space, orbital instruments with clear, steady views sweep across the same region, logging frames where Atlas is only a display speck among many stars. Later, these frames will be aligned and deepened, each adding another layer to the picture of how Atlas presents itself from this new angle. For now, the work remains simple and calm. Telescopes continue listening to Atlas's light, tracking the guest as 3 Atlas moves into geometry that reveals more of its structure and prepares the way for deeper, refined images in the nights ahead. On many screens, the raw images of 3 Atlas look strangely disappointing at first glance. Single exposures show almost nothing more than a slightly smeared star, and Atlas appears stubbornly ordinary. Observers know that light from 3 Atlas is thinly distributed across only a few pixels. Noise from the detector and the faint glow of sky stand nearly as tall as Atlas's signal. When a live stream shows only these single frames, viewers see a soft dot and little else. Some conclude that 3 Atlas has no real tail, no dramatic structure, just a tiny blur among stars. Astronomers work differently with Atlas. Instead of trusting one frame, they collect many exposures, each one a brief imperfect glimpse of 3 Atlas. Later, these frames are carefully aligned on Atlas's motion, not on background stars. Stars then stretch into lines or vanish into fuzz, while light from 3 Atlas quietly adds up in one place. This process, called stacking, lets the true shape around 3 Atlas rise slowly above noise. The coma grows clearer, and a tail begins emerging from the glow, a faint extension pointing away from the sun. On some stacks, narrow streamers appear, jets reaching from near 3 Atlas's hidden nucleus into space. These jets are absent in any single raw frame, yet they're consistently written across many images of Atlas. The anomaly is not in 3 Atlas's behavior, but in how different eyes look at the same light. One set of eyes sees only unprocessed clips and thinks nothing is happening, while another sees the stacked structure around Atlas and reads a more complex story. For those working with long exposures, this is a familiar lesson that 3 Atlas quietly repeats. Reality can sit below the threshold of a quick glance, waiting for patient accumulation before revealing its outline. As you listen, the idea feels gentle rather than technical. 3 Atlas invites a slower form of seeing, one in which many small moments combine into one clearer picture. Just as your thoughts from the day can soften and merge while you rest. Like stacked frames around Atlas, scattered impressions merge into a calmer picture, preparing you to follow 3 Atlas into deeper, quieter sections of the night story. In recent updates, mission schedules and press notes quietly mention a new target on NASA's list, and the name used is simple. The object is labeled as a comet, and that comet is 3 Atlas. On official graphics, Atlas appears alongside familiar solar system comets, shown with a coma, tail, and standard comet icon. The language sounds confident, as if Atlas's behavior has settled into a category astronomers know well. Data from spacecraft and major observatories are grouped under headings that speak of cometary activity, and Atlas fits the description in many ways. 3 Atlas carries a diffuse coma, sheds dust and gas, and responds to sunlight and solar wind in patterns that resonate with comet physics. Yet for those who remember how 3 Atlas arrived, the label feels slightly too small. Atlas did not emerge from the Kuiper belt or Oort cloud we map around the sun, and Atlas's orbit is hyperbolic, pointing outward to another star. In quiet conversations and longer analyses, some researchers still prefer calling 3 Atlas an interstellar object. This phrase preserves the feeling that Atlas belongs first to deep space and only briefly to our comet family. The anomaly is not that NASA calls Atlas a comet, but that both descriptions can be true simultaneously. 3 Atlas can behave like a comet in the inner solar system while still carrying the history of an object born elsewhere. From a narrative distance, the dual naming gives Atlas a double identity. During this close passage, Atlas wears comet-like features, yet 3 Atlas's long path through interstellar space never entirely disappears. For you listening in darkness, the tension is gentle rather than troubling. You can hold both images of Atlas at once, a comet in our sky and a traveler whose story began far beyond it. In this sense, 3 Atlas mirrors your own experience. By day, you belong to one world and one routine, and by night, you drift into a wider, quieter space that only dreams can visit. As the chapter fades, the label matters less than the motion. 3 Atlas continues along its open orbit, and you continue to settle, letting the mind accept that not everything needs a single perfect name before you can rest. Sometimes 3 Atlas's story is told not by what we see, but by what hasn't appeared yet. Screens refresh, mission timelines advance, and still, the next clear image of Atlas doesn't arrive. In deep control rooms, raw frames must be checked, calibrated, and compared before anyone is sure what 3 Atlas is really doing. Data pipelines are long, passing through instrument software and human review before Atlas is ready to be shown to the public. On the outside, this delay feels like a pause in 3 Atlas's narrative. People watching for Atlas may look up schedules and expect an image on a certain day, only to find empty slots and quiet headlines. Numbers don't disappear, but they move slowly. Bits from spacecraft drift through antennas and servers, and 3 Atlas waits in those streams, wrapped in compression and error checks. When nothing new appears on public pages, some wonder whether something about 3 Atlas is being held back. Others know that silence often means only that the work of understanding Atlas is still in progress behind closed doors. The anomaly is the gap between expectation and reality. Our minds move quickly, but 3 Atlas's journey and the treatment of its data move at a steadier pace. In that gap, imagination begins tracing its own lines around 3 Atlas. We picture bright, dramatic changes or secrets hidden in missing frames, filling the quiet with stories Atlas hasn't actually told us. From a calmer distance, silence itself becomes part of the experiment. If we listen carefully, we see that 3 Atlas is also a lesson in patience, reminding us that not every moment of discovery arrives on demand. You can let this idea soften the edges of your thoughts. Just as stacked images reveal 3 Atlas's tale over time, slow, careful analysis will eventually reveal more of what the instruments have seen. Until then, 3 Atlas continues along its open path, whether we have the newest file or not. The guest doesn't hurry, and you don't need to hurry either as Atlas's story unfolds at its own speed. In the next part of this journey, attention will turn back to the sun and its flares, and to how that changing light may reach 3 Atlas. For now, the quiet between updates is simply another dark space in which Atlas glides and in which your thoughts can gradually dim. In the days since 3 Atlas rounded the sun, the star at the center of its journey has been anything but quiet. 4 times in a short span, the sun has erupted with X-class flares, each one a sudden bright knot of energy woven into the path Atlas is moving through. One of these flares climbed to X 4.0, a powerful spike even by solar standards, rising sharply on graphs that track the sun's heartbeat. While 3 Atlas drifts in steady motion, instruments near Earth record that the X4.0 flare briefly flooded the dayside ionosphere, triggering a strong radio blackout over the same broad region of the planet. On space weather plots, the 4 X-class flares line up almost like beads, each occurring within nearly the same 3-hour window in universal time. For people following 3 Atlas, this rhythm stands out. The sun seems to be ringing a bell again and again while Atlas continues its slow passage nearby. In the data, the pattern is clear and simple. Timestamps, peak X-ray flux, and mapped footprints of radio absorption agree that the flares repeat in a narrow band of the day, even as 3 Atlas moves farther along its trajectory. The anomaly lives in this repetition. The sun has countless ways to flare, yet here are 4 strong events clustered in intensity and time, playing out while the geometry between Earth, the active region, and 3 Atlas keeps shifting. Some will see only coincidence, a brief burst of activity in a long solar cycle that 3 Atlas merely happens to share. Others watching the same charts wonder quietly whether the timing hints at some deeper sensitivity in the system through which Atlas is traveling. From 3 Atlas's perspective, nothing about the flares is labeled unusual. Radiation and particles move outward at light speed and slower, filling space with waves and fronts that Atlas will meet only if paths cross exactly. For you listening in darkness, the details blur into a simple image. The sun pulses 4 times with unusual strength, like a lighthouse turning its beam, and somewhere within that wider glow, 3 Atlas continues to glide, unchanged in its calm, precise orbit. As the chapter turns, attention will shift from the timing of these flares to the positions of comets and planets around the sun. Atlas's path will be traced against that larger pattern as we follow how 3 Atlas moves through a solar system briefly playing in a higher, brighter key. While the sun was sending out those 4 X-class flares, 3 Atlas was not the only icy traveler near the fire. Along the inner orbits, other comets were making their own close approaches, and Atlas was part of a small, quiet procession, moving through the same bright arena. In late October, 3 Atlas swept through perihelion, passing closest to the sun and beginning to curve outward again. Just days later, a 6 Lemon made its own tight turn around the star, and Lemon's path crossed the same general quadrant of space that Atlas had just left behind. Further along the calendar, another object, T1 Atlas, prepared to round the sun from a slightly different angle. As T1 Atlas approached, observers traced its trajectory on the same diagrams that already showed 3 Atlas's arc, noting how these lines of ice and dust seemed to weave past one another in time. Seen from above the solar system, the picture is simple. The sun glows at the center, inner planets' orbits form thin rings, and 3 Atlas cuts through these rings while a 6 Lemon and T1 Atlas thread behind and ahead of Atlas. On these overhead maps, the active sunspot region that launched the X-class flares rotates with the sun, first facing the position where 3 Atlas was near perihelion, then the longitudes where A, 6 Lemon and T1 Atlas make their turns. The bright flares repeat as if the same magnetic knot watches each passage in sequence, while Atlas moves steadily outward along its open path. For solar physicists, the data show familiar motions. Active regions grow, decay, and flare as they rotate, with or without 3 Atlas in the scene. Yet the timing of these flares around the perihelia of Atlas, Lemon, and T1 Atlas draws quiet attention. Some researchers treat the pattern as an interesting chain of coincidences, a run of active days in which 3 Atlas and the other comets happen to share the stage. Others allow themselves to wonder gently whether Atlas's and its companions' presence marks windows when the system's geometry is especially responsive. From 3 Atlas's point of view, there is only motion. The sun brightens and softens, comets sweep by, and Atlas follows its own calculated curve, one thread in a larger tapestry that the solar system is briefly weaving. As you listen, the details resolve into a calm image of choreography. The comets arc around the sun in slow luminous lines, and 3 Atlas glides among them, part of a silent dance that will carry Atlas farther from the light in chapters to come. When the same star flares again and again at nearly the same hour, the pattern invites a gentle question about Atlas. If the timing of these outbursts clusters, some begin wondering whether the system's geometry carries a kind of rhythm. 3 Atlas moves through a constantly changing arrangement of planets and fields, a shifting lattice of gravity and magnetism. At certain moments, Lines from the sun through Atlas, Earth, or other bodies fall into sharper alignment, as though the paths briefly lock into a simpler shape around Atlas. In this view, the solar system becomes more than orbits and dates. The distances and angles that include 3 Atlas could also be read as a slow turning pattern, a potential source of resonance not yet fully mapped around Atlas. On paper, the data still look like numbers. Times, positions, and flare strengths form clean columns, and no equation yet demands that 3 Atlas must be part of the cause. The anomaly lies in how these numbers line up in time with Atlas's passage and with key alignments. Again and again, the sun shouts in X-rays, while 3 Atlas and other comets pass through nearby sectors of space, leaving room for quiet speculation. Some scientists stay firmly grounded and call it coincidence, a natural clustering in a noisy system that would happen with or without Atlas. Others allow themselves a softer thought that maybe certain configurations focusing through 3 Atlas and the planets make the star more ready to release stored energy. For now, nobody can prove that the system's shape is singing to the sun through Atlas. All that can be said with certainty is that the flares, alignments, and 3 Atlas's path are sharing the same small window in time. As you breathe slowly in darkness, you don't need a final answer. You can simply imagine the solar system as a great turning instrument with 3 Atlas moving across its strings, while the star at the center occasionally plays a brighter note. When the X 4.0 flare erupted, the first question close to home was simple. Would the wave from that blast sweep straight into Earth, or would it bend away toward the region where 3 Atlas is drifting? Forecast maps soon showed a compromise. The shock front raced outward in all directions, but the densest part of the coronal mass ejection fanned toward the western flank of the inner solar system, closer to longitudes linked to Atlas than to Earth. On diagrams, Earth sits off to one side of the expanding shell, just inside the edge of colored rings. Models suggest that our planet will feel only a glancing blow, a passing compression of the solar wind strong enough for a G1 or G2 geomagnetic storm, while 3 Atlas lies closer to the fuller body of the wave. Monitoring spacecraft like Stereo A stand more directly in the path. In projections, these probes see a sharp rise in plasma speed and density as the coronal mass ejection front sweeps past, tracing a more powerful encounter than Earth will know, and hinting at what might be happening near Atlas. For 3 Atlas, the same front may mean a short, intense change in the surrounding wind. Magnetic fields wrap and squeeze, the coma responds, and any tail extending behind Atlas could flicker, bend, or briefly thin as the wave rolls through. To space weather forecasters, there's nothing alarming in a modest G1, G2 event. Lights may dance in higher latitudes, instruments may register the passing disturbance, and then the system will slowly relax, while 3 Atlas continues its path through the region just brushed by the main pulse. The anomaly, if there is one, lies in the shared timing. A powerful flare, a directed coronal mass ejection, a mild storm for Earth, and a stronger front sweeping the sector where Atlas travels. All unfold, while 3 Atlas's story is already bound to other flares and alignments. As you rest, the scene is easy to hold. A wave passes, Earth feels only the edge, and somewhere along the wider arc, 3 Atlas drifts through the brighter part of the flow. A small, silent traveler letting the sun's breath push gently against its halo before the space around Atlas grows quiet again. For a moment, step back from the graphs and charts that follow the flares and 3 Atlas's path. Imagine the solar system laid out as a soft map of energy instead, with color and light showing where the sun's wind is strong and where it's calm, and let Atlas quietly drift across that map. On this imagined map, Earth is a small glowing circle wrapped in a gentle blue-green shell, a marker where storms become auroras instead of numbers. Farther out, 3 Atlas is a tiny ember on the western side of the sun's influence, moving along a curved line that glows a little brighter where the solar wind touches Atlas more strongly. Each flare becomes a ripple on this chart, circular bands expanding outward in slow motion. You can see the wave from the X 4.0 event sweeping across space between the sun and the place where 3 Atlas travels, a soft ring that briefly brightens as it overlaps Atlas's path. In this view, there's no urgency, only the steady passing of pulses. 3 Atlas doesn't rush to meet or avoid them. Atlas simply follows the path carved by gravity while the waves wash over and around that path. Your own body can be part of this quiet map. You lie still on the surface of a small world, and with each breath your chest rises and falls like a slow local tide, while 3 Atlas moves through a much larger ocean of particles and fields. Just as stacked images reveal more of the halo around 3 Atlas, repeated breaths smooth the edges of your thoughts. With each exhale, the details of flares and dates blur, and only Atlas's calm motion remains clear. Nothing in this pause demands an answer. 3 Atlas glides through the patterned wind, Earth turns under your resting body, and the sun continues sending gentle waves of energy. All of them parts of a single unfolding picture you're allowed to watch for a while before sleep. In the first days of January, the solar system leans into a geometry that feels unusually precise. Lines drawn from the sun through the planets begin to stack in a way that makes astronomers call this configuration one of the most important in many years, and 3 Atlas is quietly woven into that pattern. On overhead diagrams, Jupiter, Earth, Mercury, Venus, and Mars all fall close to a shared axis with the sun, forming a long, narrow chain. The same maps show 3 Atlas gliding through the outer part of this layout, not at the center but still moving within the extended shape carved by these alignments, as though Atlas is tracing the outline of a subtle design. Near the sun, inner planets pass through moments of perfect alignment called cazimi, brief intervals when they sit almost exactly between Earth and the star. In this season, more than one planet reaches that position, and the celestial clocks record successive chasmes, while 3 Atlas continues its slow outbound fall from perihelion, sharing the same broad window of time. From a data standpoint, the configuration is simply rare. Orbital mechanics show that bringing so many planets into a nearly collinear arrangement happens infrequently, and 3 Atlas's presence inside this geometry adds an extra layer of interest because Atlas doesn't belong to the sun's long-term family. The anomaly is not that planets align, but that several significant alignments cluster together while an interstellar guest is still near the inner system. 3 Atlas moves along a path set long before this epoch, yet in this chapter of its journey, Atlas happens to pass through a stage where many gravitational and magnetic influences overlap. For some, this is only coincidence written in orbital periods and angles. For others, the shared timing suggests a kind of heartbeat in the system, a moment when the combined pull of planets and sun may shape how energy moves, with 3 Atlas acting as one more small node in the network. In the quiet of your room, there's no need to decide which view is correct. You can simply picture the solar system as a long, luminous corridor with planets spaced along its length, and 3 Atlas drifting through one section of that corridor while everything briefly lines up. As the alignment builds, Earth continues its steady orbit, and 3 Atlas continues its slow, precise arc. Atlas's story will soon turn from this large-scale geometry down toward the shifting crust and oceans of a single world. But for now, the scene remains wide and calm, a rare arrangement that 3 Atlas is passing through without haste. Far from the calm room where you're resting, seismographs along Japan's coast draw quiet lines that sometimes jump. Over recent days, these instruments have recorded a cluster of small and moderate earthquakes offshore, a swarm of gentle shudders along the edge of a major fault unfolding while 3 Atlas continues its own silent motion far above. On global maps, the dots marking these quakes form a loose chain in the ocean, all near the boundary between plates where past great earthquakes have begun. For people who study such patterns, this swarm's timing overlaps with the days when the sun released its sequence of X-class flares, the same flares that trace part of the background for 3 Atlas. The data show magnitudes, depths, and times. Many of the shocks are relatively shallow, and they cluster in a region remembered for the powerful event of 2011, a memory that makes experts watch more closely but doesn't guarantee a repeat, just as 3 Atlas's past path doesn't dictate its future. The anomaly for those who notice lies again in the coincidence. Solar activity has climbed, geomagnetic conditions have stirred, and during the same window, a swarm appears offshore, all while 3 Atlas moves through a phase of its journey linked to planetary alignments. Most seismologists remain careful and calm when they speak about it. They know that swarms can fade without leading to anything larger, and that the connection between solar disturbances, deep Earth processes, and 3 Atlas's path is still a field of open questions rather than settled answers. In their reports, the language stays measured. They note elevated activity, outline scenarios, and remind everyone that Earth's crust is always in motion, whether the sun is quiet or flaring, whether 3 Atlas is in our sky or already gone. From your vantage point, this becomes a gentle reflection instead of a warning. Our planet flexes and adjusts along its faults. The atmosphere shivers under space weather, and 3 Atlas glides through the outer layers of this environment, a distant witness to the way Earth continually reshapes itself. As you breathe slowly, you can let the idea settle. The constant movement is normal, not strange. Plates shift, oceans roll, the magnetic field bends, and 3 Atlas passes overhead. All parts of a world and a guest that keep moving whether anyone is awake to watch or drifting safely towards sleep. High above weather and clouds, Earth carries a quiet structure made of trapped particles and field lines. This structure is the radiation belts, overlapping loops of charged particles circling the planet, and Atlas is moving through the broader space where these loops unfold. From the side, the belts look like 2 bright donuts, one closer, one farther out, wrapped around the magnetic equator. Solar storms can squeeze and stretch these shapes, and during the recent strong activity, models suggest that the belts have been reshaped in ways that matter to 3 Atlas's path. After a powerful storm, extra populations of particles can become trapped. Sometimes a 3rd or even 4th temporary belt appears, a new ring of radiation layered between the others, while Atlas glides through the same heliospheric environment just beyond the immediate reach of these rings. Satellites moving through these regions see their instruments respond. They measure changes in particle flux, watch boundaries shift, and help describe the invisible architecture surrounding Earth, while 3 Atlas continues on the far side of this magnetic cocoon. The anomaly is not that the belts change, but how long changes can last. A single strong event can leave the radiation environment altered for weeks or months, creating a new normal around Earth even as Atlas has already moved farther along its outbound track. Scientists speak carefully about what this means for the planet's deeper layers. They know there's a connection between the space environment, upper atmosphere, and solid Earth, but the exact pathways remain uncertain, and 3 Atlas passes through this system while many of these questions are still open. In some models, waves launched in the belts propagate downward, nudging currents high above the surface. These currents can shift how energy and particles flow, adjusting conditions that aircraft, satellites, and even auroras experience, while Atlas drifts in the larger sunlit sea of plasma beyond. For you lying in quiet, it can be simpler than diagrams. You can imagine Earth wrapped in soft glowing bands of charged light, a layered blanket that shields and shapes the space around the planet, while 3 Atlas moves through the sun's outer weather. The details of every interaction don't need to be solved tonight. Earth continues turning under its luminous blanket, the belts slowly reorganize after the storm, and Atlas follows its patient path through the same changing environment. As this chapter eases toward the next, focus will shift from mechanisms to meaning. The story will return to the question of what a guest like 3 Atlas might represent to a world watching these subtle changes, and how Atlas can become a quiet reminder of our place inside this layered living field. There's a softer way to look at 3 Atlas, one that doesn't ask for proof or fear. In that view, Atlas is less a threat or a mystery to solve, and more a quiet reminder that the universe is still sending us questions. Some people imagine that 3 Atlas could be a kind of constructed object, a probe wrapped in dust and plasma. Others see Atlas only as a natural shard of rock and ice from another star, behaving like any comet would in the inner solar system. The data we have on 3 Atlas don't force us into either story. They show activity, a coma, a tail, changing light curves, and hints of non-gravitational forces, but they don't tell us what Atlas means. In the spaces between those measurements, our own thoughts lean in. We project hopes, fears, and curiosity onto 3 Atlas, turning Atlas into a mirror for how we feel about being small in a large cosmos. From that angle, it matters less whether 3 Atlas is a relic, a machine, or a wandering fragment. What matters is that Atlas arrived at a time when we're able to notice, record, and wonder, joining its path with our brief ability to pay attention. The anomaly then is inside us, not inside 3 Atlas. We're the ones changing the story around the guest, turning numbers into narrative, and letting that narrative reflect our state of mind. As you sink deeper into rest, the lesson from 3 Atlas grows quieter. You don't have to decide what Atlas is to let its presence calm you. Atlas's motion through the solar system and your motion into sleep belong to the same flow of time, where mysteries can simply exist without being solved. Tomorrow, observers will continue stacking frames and models will keep refining 3 Atlas's path. Tonight, you're allowed to simply breathe, let go, and drift alongside the guest that moves beyond noise, beyond light, carrying the silence between stars through the last nights when we can still follow its path. 3 Atlas quietly passes, and you quietly rest. Both are allowed to simply be. On November 24th, observers around the world noted a milestone in their tracking logs. 3 Atlas had crossed what some called a psychologically significant boundary, 300 million kilometers from Earth. The number itself carries no special physics, no sudden change in the forces acting on Atlas or our planet. Yet for those following the daily updates, 300 million kilometers feels different from 301, as though 3 Atlas had stepped closer to a threshold that makes the visitor more real in our minds. The distance continues shrinking at roughly 2 million kilometers each day, not because 3 Atlas is accelerating toward us, but because Earth itself is moving almost directly into the region of sky where Atlas passes. Our planet follows its orbital curve, and for these weeks, that curve happens to point toward the space through which 3 Atlas is gliding. In a sense, we are approaching Atlas as much as Atlas approaches us, 2 bodies on intersecting paths through the wider dark. From 3 Atlas's perspective, the sun has already released its grip. Atlas moves outward now, rising away from perihelion along a tangent that will carry it back toward interstellar space. Earth's motion creates the illusion of pursuit, a temporary closing of the gap that will last only until mid-December. On December 19th, the models show Earth and 3 Atlas will reach their closest point, approximately 269 million kilometers apart, still more than 1.5 times the distance between Earth and the Sun. After that date, the geometry reverses. Earth will continue along its annual loop while 3 Atlas climbs steadily farther from the inner system, and the gap between them will widen with the same quiet inevitability that brought them together. For now, the encounter continues, and those tracking Atlas can watch the numbers fall. 300 million, then 298, then 296. Each update a small confirmation that the visitor still glides along the path that gravity and ancient momentum carved long ago. In research centers and control rooms, analysts continue refining their calculations. 3 Atlas experiences non-gravitational acceleration, subtle pushes from the gas and dust streaming off its surface, which means the orbit cannot be predicted by gravity alone. Each new observation helps calibrate the model, adjusting the expected trajectory by small fractions that add up over weeks and months. The latest revisions confirm that 3 Atlas will not cross inside 200 million kilometers from Earth under any reasonable scenario. The visitor remains distant, observable but unthreatening, a guest passing through without disturbance. For Avi Lёb and others who watch with particular interest, these weeks carry extra weight. Lёb has suggested publicly that if 3 Atlas survived its close passage around the Sun intact, we may need to reconsider its nature, not as a natural comet, but as something else. Perhaps something constructed. The argument rests on observations of Atlas's apparent resilience and its behavior under extreme heating, patterns Lёb finds inconsistent with expectations for ordinary cometary ice and rock. Most researchers in the field remain cautious. They note that interstellar comets are rare, and our sample size is vanishingly small. Only 3 such objects confirmed so far. Without a broader statistical base, it's difficult to say what should be considered normal for visitors from other stars. 3 Atlas may simply be teaching us that comets born in distant systems can be more robust, more varied, or structured in ways we haven't yet seen in the Sun's own family. On November 24th, Lёb posted an update noting that 3 Atlas appears to have adjusted its course and may now be heading toward Jupiter. The statement refers to Atlas's trajectory after the latest non-gravitational acceleration, which has shifted the outbound path slightly. If Atlas continues on this revised course, it could pass through Jupiter's Hill radius, the region where Jupiter's gravity dominates over the Sun's, potentially allowing the giant planet's pull to further alter Atlas's velocity and direction. Whether this happens by chance or design remains an open question, one that will be answered not by speculation, but by continued observation. Over the coming weeks, telescopes will track 3 Atlas as it moves through Virgo and then into Leo, watching for any further changes in brightness, structure, or motion. The James Webb Space Telescope and Hubble will turn their instruments toward Atlas during the December approach, capturing data at wavelengths that reveal composition, temperature, and the fine details of any jets or outgassing. For you, resting in the quiet, these details can settle into a simpler picture. 3 Atlas continues its journey, Earth continues its orbit, and the universe continues unfolding in patterns too large and slow for any single mind to hold completely. You don't need to solve the mystery of 3 Atlas tonight. You don't need to choose between natural and artificial, between comet and probe. You can let the visitor remain what it is, an object moving through space, carrying questions with it, reminding us that the cosmos still holds doors we haven't opened and stories we haven't yet learned to read. As December approaches, the nights will carry Atlas closer in apparent terms, and the instruments will gather more light from its distant glow. Somewhere in those photons may lie answers, or simply more questions, each one a thread leading deeper into the weave of how the universe makes and moves its travelers. For now, you can rest, knowing that the work continues without you, that Atlas glides on whether you watch or sleep, and that the story will still be there when you wake, patient, unfinished, and quietly unfolding under the same stars that cover your window and the long path of 3 Atlas alike. As your breath slows and the edges of thought begin to blur, the image of 3 Atlas can fade into the background, along with the stars, the planets, and the soft hum of the world turning beneath you. The visitor from another system passes through our sky for these brief weeks, and you pass through these brief hours of night, both journeys part of a larger motion that needs no explanation to be complete. Let the questions about Atlas drift away with the darkness. Let the numbers and diagrams dissolve into the formless space before sleep. 3 Atlas moves in silence, and you move towards silence. And in this moment, both are enough. The universe does not ask you to understand it fully before you rest. It only asks that you breathe, and trust that the patterns will keep turning whether you hold them or let them go. So let them go now. Let 3 Atlas carry its mysteries onward through the dark, and let yourself sink gently into the same dark, where all motion becomes stillness, and all questions become the quiet that comes before dreaming. The stars will still be there tomorrow. 3 Atlas will still be there tomorrow. And so will you, rested and ready to wander again when the light returns. For now, there is only this, the soft rhythm of breath, the weight of your body against the mattress, the distant glow of a visitor from another star moving through space too far to touch but close enough to imagine. Close your eyes. Let the story of 3 Atlas become a gentle hum in the back of your mind, a lullaby sung by gravity and light, by ancient ice and distant suns. Sleep now, as 3 Atlas glides on. Sleep, as Earth turns beneath you. Sleep knowing that the cosmos holds both you and the visitor in the same vast quiet where all travelers, near and far, brief and eternal, are finally, peacefully, at rest.